The client of this project is Shelter Global, and we are required to build 10 displacement shelters in Haiti after the earthquake in 2010. First off, it was important to find local manufacturers for the materials which will be used. This was mostly successful as the major construction materials do have local suppliers, such as Accueil de Haiti for our cinder blocks and plywood, and EPS Haiti for our EPS insulators. Steel corrugated sheets and steel mesh were also found locally. One of the top priorities for the client is the environmental impact of the project. Bamboo was used for the most part of the shelter, as it has properties which withstand earthquakes more than traditional construction materials in Haiti, as it can bend easily without breaking and can be used in different shapes, as plywood, which will be used in this project. Bamboo has major environmental benefits for Haiti. It is one of the fastest growing plants in the world and is also locally available. It is also becoming more widely used in Haiti, where it is now being used to build schools and nurseries by builders which have no experience in construction, showcasing the ease of building using this material. Bamboo is also a solution for probably Haiti's biggest environmental problem, deforestation. A 2018 study by Blair Hedges et al. Shows that Haiti has less than 1% of its original primary forest, and this is mainly due to the lazy management of cutting down of the trees. As this project requires bamboo trees, it is just as important to focus on the replantation and attempt at spreading more greenery in Haiti. This picture speaks on Haiti's deforestation issues for itself, showing Haiti on the left-hand side, dry and empty, and the Dominican Republic on the right. The environmental considerations do not stop at bamboo. EPS insulation will be used in the houses. It is 100% recyclable, made out of 90% air and 2% plastic, has high compressive strength, and has no global warming potential. Rocks which can be also locally found will be used for the gabion baskets, which are fit for the purpose of foundations and are easy to assemble and are recyclable. This plays a part in achieving an A+ grade for carbon dioxide emissions. Water is also a major issue. Cholera is a disease born from water contamination which is spread in Haiti. Therefore, water treatment is a must, and one of the ways will be through harvesting of rainwater, which will be explained later on. Another is sodis, which is basically filling up of clean bottles with water and leaving them under the sun for a specific period of time, depending on the season. And studies have shown that this decontaminates the water and makes it clean enough to drink. The safety of the workers must also be ensured to the client Shelter Global. Here we have a risk assessment of the construction, which includes the hazards due to sun exposure, vehicles, and falls. The risk is highlighted using a red color and a number, where hazards such as trips and falls are very likely and have severe consequences. Now on to the next part of the presentation.
As the designer team, when it comes to material selection, Revit model really help in the sense that it allows us to have all information stored in one place and could be accessed easily to all parties. Moreover, it also helps us a lot in communicating our material choices to the teammates, as we could manipulate the visual and graphic effect of the model for others to understand better. For example, the exploded Revit model as shown in the slide, with the Revit function, we are able to isolate each and every single component of the shelter and assign relevant information such as maintenance and fire protection information to it, and this really speed up the whole communication process. Material-wise, it decided that the CNC mill bamboo plywood will be used to build the main shelter structure. This is predominantly because of its high strength features while lightweight enough to minimize casualty during emergency. It is also a locally available building material to replace the overexploited timber. For the foundation, gabion basket strip footing is implemented due to its flexibility to sit on any ground condition without the need of any excavation and heavy machinery. One thing worth mentioning in our rainwater housing system is that the gutter and contour are made by bamboo, which make it a sustainable solution in Haiti.
Considering the demographics of Haiti, we have assumed a workforce of approximately 24 people. The program, once the materials have been delivered to site, will begin with all 24 working on the first shelter. That way they can learn the way it goes together before dividing into 3 teams of 8. This allows for 3 shelters to be constructed simultaneously, avoiding congestion bottlenecks, particularly at the roofing stage. We've assumed an average 3-day build period per shelter per team. It is likely that it may be slower at first and increase in speed with repetition. For the construction sequence, the gabion basket foundation will be placed first. Next, beginning with the outermost beams, the floor grid will be constructed. Then the inner columns and the wall construction before completing the floor paneling. Moving on to the roof construction, again beginning with the beams grid. Then the roof panels, finishing the roof by screwing down corrugated sheets. The final step is to complete the outer walls with cinder blocks. At the end of the shelter's life, the outer wall is the only part of the structure that will need to be demolished as opposed to disassembled. Once the outer wall is removed, the demolition will follow the construction sequence in reverse. All the constituent parts can be reused or recycled. In the case of building on a sloped surface, we'll use a cut and fill technique with an excavator.
For this slide, the 3 construction phases were made using the Revit model to better showcase our envision of the completed shelter arrangement. For phase 1, site setting out is a must before carrying out any construction such as surveying the land to observe if any flattening of the ground is needed. After that, site hoarding will be placed surrounding the desired location to act as a safety barrier to clearly separate the construction site. For phase 2, it can be seen that some shelters are completed while part of it are still under construction. The materials delivered on site will be covered with waterproof tarps to ensure that it is protected in the event of extreme weathers. For the final phase, this shows the desired arrangement of the shelters and cisterns.
Using the precipitation data collected online and some logical assumptions made, we are able to calculate the monthly water inflow and outflow of a rainwater housing system. With that, we could then work out the amount and size of the system that we need to optimize the whole system.
This slide shows the calculated value for EC of one shelter. The Revit model made this easier as each element had the volume provided in it. The calculations were simplified into A1 to A3, A4 and A5. For each section, we listed down the different materials used, namely bamboo plywood, steel, cinder block and many more. As such, for one shelter, we had obtained a value of 53.5, which is an A+ rating.